Anyway, I think it's funny. All right, so we are going to do natural exponential function today. Do you all remember our good friend E?
No.
E is equivalent to 2.71828, on and on and on and on. It's just like our good friend pi. We celebrated on February 7th.
Is there an E day?
We will have an E day for you, Jack. It is an irrational number, meaning just like pi, it goes on forever. It cannot be written as a fraction. It doesn't end. Shh. Okay, I do want you to write down, because we are in calculus, the limit definition of E. And we will be applying this later on in the chapter. But the limit definition of E is actually the limit as x approaches 0 of 1 plus x to the 1 over x equals E. And that right there is actually equivalent to E. And like I said, we'll be using this later on in some lessons, but at least you can look familiar. This should look familiar to you. We're about to do this today, a similar formula. That this should look familiar.
That limit to the x is 0, I'm honestly confused.
Not good. All right, so we're going to sketch these two. F of x equals e to the x, and then f of x equals e to the negative x, okay? And if you don't remember, the E button is on your calculator, okay? It is located right where it says ln. Right above it is e to the x, okay? So I do want you to make a table of values, which some of you did make last night for me. I was very thankful. Thank you so much for making. I'm going to make a very weird shaped table of values right now. Make it like that. Make it sideways. I do like -2, -1, 0, 1, 2. Those are always your best ones. And by the way, let me give you just a little life lesson right now while we're sitting here talking about that. Guys, when you go to take Calc 2, actually, when you go to college, you want to give the professor more. You want to show them that you are more than adequately capable enough to take this course. So when they ask you to sketch something as simple as e to the x, and all you give to them is a picture e to the x, show them something extra, like plugging in a chart. Show them, that you can solve an equation. Show them the extra stuff. I know you're like, but I know how to do it. I know what it looks like. It's going to be exponential. I know show them extra. Okay, you want to show them that you have a brain. All right, that's, I think, the biggest problem with my students that go to college. They just don't want to, we don't want to do it the professor's way. Why? He's the one grading it. Or you want to do it their way. But Mrs. Steady, you showed us this way. Okay, but do it their way. Make them happy. All right, so let's do this right here. E to the x, so e to the -2. And again, you can use your calculator for this portion because this is actually going to be a number. E to the -2. Use your little button there, and I get 0.135. And then we're going to do e to the -1. E to the -1, and I get 0.368. Now this one I'm not going to use a calculator for because e to the 0, anything to the 0 is what? 1. E to the 1, well, we know what e to the 1 is. What is e to the 1? Look above your notes. 2.72. And then this is e squared. And e squared is, let me see, I think it's 7 point something, 7.39. Okay. What would happen to this chart over here? What would be the only difference now? If this is now -x?
It's fraction. It's not negative.
It's just flipped. So your -2 plugged in here would actually become e squared. So that would be the 7.39. This would become e to the 1, 2.72. This would still be e to the 0, et cetera, et cetera. Now, what you just need to know and recall, this e is a number, y'all. This is just like 2 to the x, 5 to the x, 7 to the x. It's 2.78 whatever to the x. So it's still going to look like an exponential function. It's still going to get really tight along the axes. It's still going to cross through 0, 1. Look, it's up here, 0, 1, it's crossing through. But the cool thing is it actually now crosses at 1, it crosses at the point E, 1 comma E. Interesting. And then obviously the flip would do 0, 1 here, but then you would actually, this point would be negative 1E. Okay. So pretty cool. Just realize that. Again, you can use your calculator for that, but you really should recognize and recall that. Now, we're going to simplify, we're going to solve, and we're going to do some application today. We're done. I mean, this isn't that hard. This is just all review from pre-calc stuff. So let's do some, we'll call this part 2, simplify. E to the 3 times e to the 4. All right, we'll do these 4 quick problems right here. I'll move it up. Okay, again, E is a base, just like base 2, just like a base 5, just like what you were doing last night for homework. It's the same rule. You keep the base and you do your exponent rules. So number 1, e to the 3 times e to the 4 would be what? E to the 7. Done. Don't tell me what e to the 7 is. You don't need the decimal. Just leave it as e to the 7. E to the 3 to the negative 2 would be e to the what? Which is what? 1 over e to the 6. Done. Okay. E squared to the 5 halves would be e to the 5th. 2 times 5 is 10. I can't believe you still don't know fractions. Divide by 2 is 5. God bless you. All right, last one. If I have a negative in the bottom, I elevate or pass. So how many e's do I have now? 7 on the top. There's my 7. There's my new 7 with a cross through it, so you get happy. Can you do all that? Yes, you can. All right, now you ready to solve? I'm just waiting on Jed.
Yeah.
Okay. You got it, Jed?
Yeah.
These are chump change, I know. This is where Gabe in the last class was like, this is so easy, and then when I do the problems, they're nothing like that. I'm like, yes, they are. It's not true.
Why is that facts?
That's not facts. 7x to the 2/3 equals, and then 8. I'll do these 3. All right, so for the first one, you have a base E, you have another base E. That's what you want. You want them to be the same base. That's what we were doing yesterday. We were changing everything to a base 2 or a base 3. These are both base E's. So if they're the same base, then you set the exponents equal. What's the exponent right here? Understood? 1. So set the exponents equal. What does x equal? Negative 1/3. Done. What about over here? This is a base. This is a base. Same base. Then you can set the exponents equal. So square root of x equals 3. How do you undo a square root? Square both sides. So x equals 9. Done. Yes, no, maybe so. Are you with me? Okay, now, these are not the same base because you're actually solving for x, which is the base. So you have to undo whatever is happening to the x. How do I undo a 2/3? What did I learn yesterday? I reciprocate it to a 3/2. Now, again, this side, by the way, is e to the 2/3. So you are going to raise it to a 3/2. Now, we just learned this. This is the mistake I did yesterday's lesson. This is the mistake I did. When you raise it to an even power, you're taking a square root, right? 1/2 is a square root. Anything with a half or a fourth, that's an even root. So write this down. Because you are square rooting, I don't even know if that's a word, it, you must have 2 answers. Okay? Because I've tried to train that in you, and of course, Mrs. Setta made a mistake yesterday, her own self. But anytime you raise to a half or a 3/2 or a 1/4 or a 5/4, whatever, you are taking a square root. You're taking an even root. So you need a plus or minus. So these will cancel. X equals, and then this will cancel, and you'll be left with E, but not really. You'll be left with what in front? Plus or minus E. 2 answers, yes, plus or minus E. That's where it came from. All right, and then this last one, again, your job is to get X by itself. Since it's not in the exponent, you can solve it like you normally would since Algebra 1. I don't like that 3. Can I divide both sides by 3? Sure can. Divide by 3. X cubed equals 3E cubed. Now what would I do? How do I undo a cube? Cube root. Do I need a plus or minus? No, I just cube root. Cube root. Now here's the only thing extra you could do. You cannot take the cube root of 3, but could you take the cube root of E cubed? What is the cube root of E cubed? E. So you're going to pull out an E, and then you're going to write cube root 3. Some books have the cube root 3 in the front because they like their numbers in front. I don't like it written that way because it looks like the E could be underneath the radical, so I just leave it like that. All right, so you'll have some problems to do like that tonight. All right, fourth and final thing. Yay, see, we're doing it so fast and so easy. Compound interest. This is where all my business majors in here are going to have to spend most of the rest of their life. Compound interest. The compound interest formula is A equals P times 1 plus R over N to the N. I'm not going to use that one. I'm going to actually use this one, which is the compound interest N times per year. Oh, I don't know what happened there. I think that was supposed to be an N. N times per year. This is the one that P stands for principal amount. That is, for example, if we're talking about student loans, that would be the amount of student loan that you're taking out. I'm taking out $35,000, okay? That would be your P. Or if you're talking about getting money, that would be like, my grandma died, she gave me $5,000 and you put it in a bank. That would be the money you put into the bank, okay? So you don't want to touch this money. You want it to accrue some interest. You want to get some money from it. That's what the A is for. The R is the rate from the bank that you are taking out that student loan. It is always written as a decimal. It will be given to you as a percent, but you need to write it in this formula as a decimal. So they'll say 5%, then you put what here? 0.05, okay? Some banks will be like, oh, it's only 1% compounded daily. And you're like, oh, that's not good. All right. The N represents the amount of times compounded. Meaning, let me go over here and make a little chart, okay? If it says annually, you would have N equal what? 1. If it says semi-annually, you would actually have N equal 2. Do you know what N equals 4 is called? Quarterly. And what would N equals 12 be? Monthly. And what am I missing? And then daily is what? 365. Okay. If you owe a student loan, your bank is going to be up in here. Just so you know. Okay.
If it's like biannually, is that 0.5? Or is that like every 2 years?
Biannually might also be the same as semi-annually.
Oh, yeah.
Okay. Yeah.
Is it like plants? Perennial?
Yeah.
Is it like every 4 years?
I have to think like Jed when he starts saying, is it like plants? I have no idea. T is years. Yeah, plant-based. T is years, but listen to me. Year meaning, so if you're going to put the money into the bank, but you're doing it for 6 months, you're not going to put 6 here. You're going to put what? 0.5. If you're going to put it in the bank for only 11 months, you're going to put 11/12 right here. You see that? You'd actually have to convert. All right. The last one is compounded continuously. And compounded continuously, I spelled it wrong. That's okay. When they say compounding continuous, then you use this formula, A PERT. Do you remember A PERT? And it's not, the R and T are not next to the E. The R and T are the exponents of E. And the R still represents rate. The T still represents time in years. The E is in your calculator. Okay. All right. So let's do an actual problem from our homework tonight. You're very lucky. I'm doing this question for you. This is question 32. This is your last question because you know how you are. You get to question 32 and you're like, I'm not doing it. I'm not doing it. But it's actually not that bad. Okay. She's like, why am I late? So this is a chart that they want you to fill out. And number 32 says they gave you a principal of $2,500 at a rate of 5% for 20 years, and you are to fill out the chart. So I wanted you to see what it looks like, but we're going to do this together. So here's number 32. Let me give you all the given information. They told you that your principal that you're putting in is $2,500, a rate of 5%, which would be what as a decimal? 0.05. Your time is 20 years. Okay. And you are to fill out the chart that looks like this. 1, 2, 4, 12, 365, and then compounded continuous, which I will do it in a minute. Now, I want you to do this with me. Let me tell you why. Every year I put this on the quiz. And I think to myself, this is just a give me freebie question. And every year, half of you get it wrong. Not just like 1 or 2, like half of you get it wrong because you don't know how to put it in your calculator correctly. So here's what I mean. This uses this formula. P times 1 plus R over N to the NT. You got to memorize that, okay? So let me move that down. So what am I going to put for P? 1 plus my R is 0.05. My N, well, that depends on what's here, so I'll do that in a minute. To the N times T, so that would be 20N. Okay. So let's see if we can do this correctly. This one should actually be easy. You should always get the number 1 right because you're dividing by 1. That's not that hard. So it's really just 2,500 times 1 plus 0.05 to the power of 20. So I got 6,633.24. You always go to 2 decimals, business majors, because why? Money. We're talking about money. They want to make, the bank wants to get every cent from you if you've heard of that before. They will take you for every cent. Okay. Now, when I do number 2 in here, I just want you to watch what I do. It depends. I actually do it a couple different ways, but I would type 2,500 times 1 plus, and then I actually put in its own parenthesis, 0.05 divided by 2 in its own parenthesis. You see that? Then I raise it to the power of 20n, so 20 times 2. 6,712.66.
What's the first one?
6,633.24. All right, and then et cetera, et cetera. I'm assuming you can all see how I just did that one. That's how I would do it. I always do double parentheses. We'll do this one real quick, 365, just to show you what that one would look like. 2,500 times 1 plus parenthesis, 0.05 divided by 365, close the parenthesis, to the power of 20 times 365. So after 20 years, if you put $2,500 in the bank, you would make $6,795.24.
That's nothing.
On the 365.
And then 365. If it's compounded
Wait,
daily.
That's, no.
Now, what do I have to do differently here? Compound continuous. You use APERT. So you have to use PE to the RT. You have to do 2500 E to the 0.05 times 20. So you actually would use your calculator and do 2500 E, and I just do 0.05 times 20. I actually let the calculator do all that work for me, and I'm going to get 6795.70. Just a slight increase from daily. So again, if you can go to the bank and read your fine print in your student loan, your student loan might be up here more like that. Okay. All right. So here's what I'm going to give you time now. You are going to do tonight's homework. Get as much as done of that as you can, which is right there. 2 through 22, even 28 and 32. Finish 32. I didn't do all of them. You can finish all of them. And then we are going to, we are way faster than the other.